So today we're going to look at Learning Target 1.2, which I probably should write up here, and we are going to be solving two-step linear equations. Now, this box over on the right side, this first step isn't going to come into play with solving two-step equations. We won't need to simplify each side of the equation, but that will come into play when we solve multi-step equations later on. I would highly encourage you to do like a little dashed line down through your equal sign vertically so that you can keep your equal signs lined up. Whether you use the dashed line or not, I absolutely expect that all the way from the top of this problem until the bottom, the equal sign is always one lined up underneath another. There are some common mistakes that can happen if you move your equal signs around. So every time I look at your sheet, I expect to see equal signs lined up top to bottom. The dashed line's just reminding me to do that. When I look at an equation, eventually I want to actually solve and find the value, in this case of x, since that's the variable, which means what I want to do is to get everything with x on one side of the equation, in this case it's any x term, and anything without x on the other side of the equation. And again, in this case it's the constant. When I look at the x side of the equation, I don't want to see an x term and a constant on the same side. Because there's a constant on the other side of 33, it makes sense to move the constant of 6 over to be with the constant of 33. Now, how do I eliminate the plus 6 on the left side of the equation? Well, I eliminate adding 6 by subtracting 6. The equals, in this case, reminds me that what I do to one side of the equation, I need to do to the other side. This equation was in balance to begin with, and as long as what I do to one side I do to the other side, that balance remains. So keeping the equal sign lined up is going to be important. I also want to do a quick vertical check to make sure that I did what I meant to do. I meant to get rid of this positive 6, and yes, I would do that by subtracting 6. That's going to leave 10x equals 27. Then I'm going to divide both sides by 10. The reason I'm doing that, my x term is isolated on the left, my constant is on the right, but this tells me that the value of 10 times x is 27, and I want to find the value of 1x. Since it's 10 times x, I undo that multiplication with division, and so x equals 2.7 for my final answer. If this was a fraction, where maybe I had something like 6x equals 4, and then I divided both sides by 6. When I plug 4 divided by 6 in my calculator, it would say 0.666666666, etc. If you get a decimal that fills up the entire screen, you need to convert that back to a fraction. If you're not sure how to use the fraction conversion button on your calculator, or you're not sure if your calculator has one, talk to me in class and I can help you with your calculator. In this case, I would expect that this answer would end up being x equals a reduced fraction of 2/3. I won't accept the decimal in that case because you had to either round it to something like 0.7 or 0.67, which means it's not exact anymore, or I won't be able to reuse it. If you did something like 0.6 with the repeating bar over the top, I could never reuse that number for anything else because I can't plug this back into my calculator. So decimals are fine. This is exactly 2.7, but if it's a decimal that I would have to round or use a repeating bar for, I need to do it as a fraction instead. The only difference between B and the previous problem is the variable is on the right side now. It's still with a constant, and there's still a constant on the other side. I'm going to talk quickly about two ways to do this problem. The way that it's set up, I don't want the variable term and the constant on the same side. Since there's a constant on the other side, I would want to move this constant to the left. To undo subtracting 59, I would add 59. And if I add 59 to the right side of the equation, I also have to add 59 to the left side. Double check. Yes, I did what I intended to do. I got rid of the 59 on the right side because negative 59 plus 59 is 0. And horizontally, here's my equal sign, and I just did exactly the same thing to both sides of the equation, so it's still in balance. So I end up with 12 equals 3x. Again, this is the value of 3 times x. I want the value of x by itself, So I would divide by 3 to solve for x, divide this side by 3, and I'd end up with 4 equals x. I do not want that as a final answer. I want you to flip it so that x equals 4 is the answer for your problem. The other way to look at this, because there's only one x variable in the entire problem, you could have started off the problem by just flipping the whole thing to 3x minus 59 equals negative 47 to begin with, and then solved it from there to eventually get your x equals 4. C is different because in this case, the thing that's on the other side of the equation by itself is a variable term and not a constant. So in this case, I don't want this constant and this variable term on the same side because there's a variable term of 5n on the other side. I want to move my 7n to the other side. To undo subtracting 7n, I would add 7n. That eliminates the n on that side. Do the same thing to the other side. Double check, yes. Negative 7n plus 7n is 0, so that's totally eliminated, leaving positive 9. And then 5n plus 7n is 12n. I want to solve for n instead of 12n. Again, since it's multiplication between the 12 and the n, I could divide both sides by 12. 12 divided by 12 is 1, so this side is now just 1n. 9 divided by 12, you could give me that as a reduced fraction of 3/4, or because it's an exact decimal, I would also accept n equals 0.75, or you could write it as 0.75. You don't have to have the 0. And if you'd circle your answer when you're done, I would appreciate that. D is the problem that too many people, frankly, just get really scared by. It's okay. Think about the fact that D honestly looks a whole bunch like what we just did. I have a variable term here with the m over negative 5, because it has the m in it. I have a constant term here of plus 3, and I have a constant on the other side of the equation. Just like we did in the previous problems, if I have a constant on the other side, I want to move this constant over. So I want to move this plus 3. To eliminate adding 3, I would subtract 3 from both sides of the equation, and I end up with m over negative 5 equals 9. Here's the difference. Here, we ended up with, in essence, 3x equals 12. The 3 was connected to the x with multiplication, so I undo that by dividing by the 3. Here, the negative 5 is connected to the m with division. Well, if I undo multiplication with division, then I undo division with multiplication. So I need to multiply this side of the equation by negative 5 to undo this dividing by negative 5. What I do to one side of the equation, I do to the other one. Now, why this works? You are not multiplying these two negative 5's together. If I turn this negative 5 into a fraction, it's negative 5 over 1. If you remember how to multiply fractions together from previous years, I multiply the numerators, so that's going to be negative 5 times m, and I multiply the denominators, so over negative 5. Notice how that actually looks a whole bunch like this 3x over 3 or this 12n over 12, which means in this case the negative 5's will cancel. Oops. And my final answer is m equals negative 45. Now I ran out of my dotted line, but notice I still kept my equal signs lined up, and my problem is done. And what E brings to the table is you will have problems with not only decimal answers, but sometimes decimals in the problem. I approach them the same way. I have a variable term here, a constant term here, and a constant term on the other side of the equation. So I want to move this constant over to the other side. The way that I eliminate the minus 4.8 on that side is to add 4.8 to both sides of the equation. Now make sure you're paying attention to the fact that this was a negative 0.48 up there. So I end up with 3.6y equals, well, 4.8 minus 0.48 is 4.32. And I can do that because 4.8 minus 0.48 is the same thing as negative 0.48 plus 4.8. So either way will work, and whichever way you feel the most comfortable with. And then the y term is isolated, the constant is isolated on the other side of the equation. The way I undo this, multiplying the y by 3.6, is divide that side by 3.6. But what I do to one side, I need to do to the other side of the equation as well. And so when I divide that out, y equals 1.2 is my answer. I would also have accepted y equals 1 1/5 there. Just like if I go back here, I would have accepted y equals 2 7/10. So as long as you give me the reduced mixed number or reduced fraction, I will accept that in addition to these nice decimal answers. And in this case, we didn't have to give a fraction answer on anything because they all worked out to be nice decimals that I didn't have to round and I didn't have to use a repeating ball. Thank you.